Okay, so here are 4 questions again. These are more grade 9 versions of the grade 8 and 7 linear relations. Uh, Slightly more probably closer to grade 8 as well. But what we're going to do here is we're going to apply the same process to find the equation that matches these tables. So we have 10x, y1, x20, y6, and x30, y11. So again, if I look for the difference in y divided by the difference in x, that will tell me the coefficient of my equation. The coefficient, of course, is a multiplier for, in this particular case, x. So the difference here is going up by 5, and the difference here is going up by 10. Now notice I'm using a positive 5 and a positive 10. So the difference in y is 5, the difference in 10 is, x is 10. That means that 5 divided by 10 is 0.5, or I can also think of it as being a half as a fraction. Now that means that I could either write it as 0.5x, or if I wanted to, half of x, or even more importantly, since half of x is really x divided by 2, a more familiar way to write the coefficient of a half is simply x over 2. Okay, that is half of x. So all 3 ways here, half of x, and half of x, are appropriate ways to express this coefficient of 0.5. All right. Now I'm going to actually use this method. I'm going to take this and I'm going to use x over 2. Simply because it's the form we've used for half of x since we started in grade 7. So half of x. If I take any of the ordered pairs, in this case, this one here, and substitute it into my equation. So instead of x divided by 2, I'm going to go 10. Oh, that's not right. 10 divided by 2. Instead of x divided by 2, 10 divided by 2 equals 1. And 10 divided by 2 is 5. And since 5 does not equal 1, the constant that is required is subtracting 4. So if I use this as my equation, what I will find, if I erase all this stuff here now, is that taking any x value, in this case 30, 30 divided by 2 is 15, and 15 take away 4 is 11. If I move it up here, oh, not that one, but the other one, 20 divided by 2 is 10, and 10 take away 4 is 6, and so on and so forth. So that's the equation that matches all of those ordered pairs in the table of values. In your next equation, I forgot I had all the space here. I forgot all about this. Follow the same pattern. So your difference in y, not your difference in x, but your difference in y divided by your difference in x will equal the coefficient. The difference in x, now watch this time. It's going from 5 to 4. So the difference is not 1. The difference here is actually minus 1. Okay? We're going down 1 each time. So every other time I used a positive symbol to show going up, I'm going to show a minus symbol to show, or a negative symbol to show going down. And this is going up by 1. So a negative 1 divided by a positive 1, which is the difference in y divided by the difference in x, equals a negative 1, which means my coefficient is negative 1. Now, of course, you've been preached at for a long, long time that you should never write a negative 1 coefficient. You should always express it as simply a negative x, because a negative x is a negative 1x. So we're going to write the coefficient as negative 1. And then we're going to take any of the ordered pair. I'll take this one here. And I'll substitute 1 and 5 in. So x is going to become 1. Y is going to become 5. And a negative 1 does not equal 5. But in order for those two sides to be equal, I need to apply a constant of positive 6. Because negative 1 plus 6 is 5. So our equation for this particular table of values is negative x plus 6 equals y. And just to prove that it does work for other pairs besides the first one, if I took this one here and substituted 3 for the x, so it's now a negative 3. Negative 3 plus 6 is the corresponding y value of 3, so it does work for that. And it would work for any other ordered pair if I extended that and graphed it and made a line and extended the line to infinity. Any pair that fit on that line would fit on that table of values. The third one gives us this table, and if we do the same process, the difference here is not going up by 2, but rather going down by 2. And the difference here is also going down by 2. So if I take my difference of difference of y divided by the difference in x, that'd be negative 2 divided by negative 2, which means it's a positive 1. Okay? What does that mean in my equation? That means there is no coefficient, because a 1 coefficient would not be written. I could put it there if I wanted, but it's inconsequential because 1x and x are the same thing. So this is interesting. That means that when I take any ordered pair and substitute it in, x is 10, y is 16, the constant that's required is simply adding 6 each time. And then when I look at my ordered pairs here, I'm like, oh, that makes sense. 8 plus 6 is 14. 6 plus 6 is 12. 10 plus 6 is 16. Yeah, it is. It's just x plus 6 equals the y value. And your last question gives you what looks like a fairly complicated table of values, but it's not so bad. Here, I'm going up by a half each time. Here, I'm going up by 1 each time. And 0.5 divided by 1, or any number divided by 1, is itself. So therefore, the coefficient is 0.5. And remember what we said. 0.5x, or half of x, or x over 2 are all the same thing. So when I go to put this coefficient in to my partial equation, I like to use this. But if you want to use the 0.5 coefficient, that is a grade 9 way of looking at it, so you can do that. That's no problem. In fact, let's just do it this time. Let's just put it as a decimal coefficient. I would have put it as x over 2, but whatever. Let's put it like that. So then when I substitute any ordered pair, this time just for poops and giggles, I'm going to substitute the second ordered pair instead of the first one. And I'm going to put 0.5 multiplied by the x value, which is 3, will equal the y value, which is 1. 0.5 times 3 is 1.5. And since 1.5 doesn't equal 1, the constant that is required is simply subtracting a half. And therefore your equation is this. Now you can write that in 2 different ways, or 3 different ways. You could write it as this, 0.5x minus 0.5 equals y. You could also write it as half x minus a half equals y. You could also write it as x over 2 minus a half equals y. Or you could write it as x over 2 minus 0.5 equals y. They're all the same thing.